people, and welcome to Teaching Sylvanus Math. Now, in the previous video, you saw that we found this pretty cool math hack on Instagram, and we tested it out with adding fractions that do not have the same denominator, and it worked beautifully. So we're going to test it out if this method works on subtracting fractions as well. Maybe throw in a negative in there. As always, I am human, so if I make a mistake, just let me know where the mistake occurs. So that way we both can learn from my mistake and I can fix it. But let's go ahead and start out with the addition one that they used in the video. And so what they used, is 3/4 plus 2/5. And what they did is they cross multiplied, so 4 times 2 is 8. 3 times 5 is 15. They added those two numbers together, so 15 plus 8 is 23. That became your new numerator, and then they multiplied our denominators together, which is 4 times 5, and that is 20. And that worked. We did 3 different examples, not including this one in our previous video, but all of them were additions. So I want to try this out with subtraction. So let's go ahead and do let's just try some out and see if it works. Okay, so we're going to subtract some fractions. So example 1, let's do that original fraction, so 3/4, but this time I'm going to say minus 2/5. So let's try that. 4 times 2 is 8. We may have to include that minus. They didn't care that it was a plus, so I'm going to leave it. 3 and 5, that's 15. I'm going to subtract that and say this is 20. So 15 minus 8, and here's 20. 15 minus 8, so I don't know what that is, so I'm going to count up from 8. So 8, 9, 10, 11, 12, 13, 14, 15. So that's 7, and then 20ths. So I don't know if that's the right answer. We're going to double check using our standard method of common denominators. So I have 3/4 minus 2/5. So I'm going to say common denominator is 20. So I'm going to multiply by 5, multiply by 5, multiply by 4, multiply by 4. So 3 times 5 is 15 over 20 minus, that's 8 over 20 equals 27. And in fact, for this example, it does work. Let's try one more just in case. So example 2, I'm going to use one of our examples from our previous question. One of them is 1 over 3 plus 11/17. And in this case, I did put a plus, but I'm going to change that to a minus by putting a negative. So this is the same thing as saying 1/3 minus 11/17. Same thing. I just happen to put an and there, and we're translating a plus as and. Right, same thing. 3 times 11, that's 33. 1 times 17, that's 17. 3 times 17, I'm cheating off of the last video, and that is 51. So I'm going to do 17 minus 33 over 51. And again, I'm going to cheat, and I'm going to say 17 plus what is 33, but I know my answer is going to be negative since I have more negatives. I have 33 negatives and 17 pluses. So how much more do I have? Well, do I have 10? If I add 10 to 17, that's going to give me 27. If I add 20 to 17, that's going to give me 37, but I want 33. So I know my answer is between 10 and 20, but I know that 20 is too much and 10 is too little. So by how much more is 20? So I need to take away 7. So I need to take away 4. So it's going to be 16. So if I do 17 plus 16, that should give me 33. And so then I have negative 16 over 51. And again, we're going to double check our usual way. So I have 1/3, I'm going to leave some space, plus a negative 11/17. Again, that's the same thing as just saying a minus. I'm going to keep it this way though. Common denominator, we're going to multiply by 17 top and bottom, and we're going to multiply by 3 top and bottom. So I have 17 over 51 plus a negative 33 over 51. So what I have is 17 minus 33 over 51, and things are starting to match here. So therefore, my answer is negative 16 over 51. So this math hack absolutely works for subtracting and having a negative. I think it's wonderful. Please use it. If you are in higher level mathematics, you do understand that this is not a formal proof. I know that. Don't have a heart attack because it's making me very uncomfortable as I do this, that this is not a formal proof. But I have shown you how to use this math hack for adding and now subtracting with a negative in our example number 2. I hope this helps you add and subtract fractions with unlike denominators. If you have any questions, please let me know. If you catch any mistakes, please let me know. As always, thank you so much for watching. Please share, like, and subscribe. That way you are notified all the time when I post videos that can help you in your mathematics. Thank you again for watching.